Okay, now we will apply Nernst equation to the Daniell cell. So if you remember, your Daniell cell was looking like this, two containers. Here anode, this is the anode, this is the convention of writing and drawing. Anode is always represented on the left side, and cathode on the left side. So you remember your anode was zinc rod, zinc solid dipped in zinc sulfate. So zinc sulfate we are representing as Zn2 plus aqueous. And if you remember, your cathode was copper solid dipped in copper sulfate solution, Cu2 plus aqueous. So this is how your anode looks like, and this is how your cathode looks like. So what type of reactions are going on separately here and separately here? So that is what I have written out here. At the anode, zinc solid is getting converted to Zn2 plus aqueous and giving out 2 electrons. And at the cathode, Cu2 plus is picking up those 2 electrons and getting converted to copper solid. So you can see in both cases there is an exchange of 2 electrons. This gives out 2 electrons and this is taking out 2 electrons. So if we are to apply the Nernst equation, then in both cases N is equal to 2 because there are 2 electrons. So how shall we write this Nernst equation in both the cases? Say if we want to write what is happening at the anode, the Nernst equation for this. So it will be E Zn2 plus slash Zn. You see I am using the convention as they are writing. So at the anode, E Zn2 plus slash Zn is equal to E0 Zn2 plus slash Zn minus RT. Now you remember N is equal to 2, so we will write 2F, and then ln of what will be here, because we are doing for zinc, so zinc is the solid out here, and what is the ion? It is Zn2 plus. We will write it in this way. And if we are to write for the cathode, it's going to be E Cu2 plus slash Cu will be equal to E0 Cu2 plus slash Cu minus RT. In this case also 2 electrons, so we will write 2F ln, what is our solid in this case? Copper. So we will write copper, and down we will write Cu2 plus. So this is how the Nernst equation looks like for the anode and for the cathode. And here I think you can see we can simplify it further because we have two solids. In this equation we are having zinc to be solid, so we can write 1 for this by convention. I have explained this already, that for a solid the concentration is always taken to be unity. So in this case this portion will become 1, and this portion also, since copper is the solid out here, this will also become 1. So instead of writing Zn, we will write out here 1, and instead of copper out here we are going to write out here 1 as well. So this is how the Nernst equation would look like. Now how do we calculate these two? Now this also calculation we have seen that whenever we calculate the E of the cell, E of the whole cell, how is it calculated? E cathode minus E anode. So whatever we get by calculation from this will give us this. E cell means E of, which is the cathode? This one. This is the cathode. So we will, whatever we calculate for this, we will write here. And E of this we will write here, anode. So then in that case, what is our cathode? Our cathode is this one. So we will write E Cu2 plus slash Cu, and instead of anode we will write here E Zn2 plus slash Zn. So this E cell, when we want to calculate, will be given by these two things. So how will we write now? How will we in this portion, how will we incorporate? See, you know, E Cu2 plus Cu is this one, and E Zn2 plus Zn is this one. So we will put down these two equations, we will substitute out here, and then what is the equation we will get? We will get E cell is equal to, we'll write this, E0 Cu2 plus slash Cu minus RT by 2F ln 1 by concentration of Cu2 plus, this will be your this thing. From here we are substituting out here, minus of this one, this we will substitute, E0 Zn2 plus slash Zn. Now there is a minus out here and there was a minus out here, so minus into minus will become plus, plus RT by 2F ln 1 by Zn 2 plus. So when we substitute, this is how our Nernst equation is going to look like. Now then what we will do, I think you can see these two have RT by 2F common, so we can take out common between these two things. So you can see in the textbook they have done it. I have marked also in page 72, it is done there. It has been substituted and it has been taken care of there. All these common things they have kept it together, and then they have okay, if you want I can do it for you. You can see. So we'll rub off this portion since we have finished to use it and substitute. So E cell is equal to, now we have a E0 Cu2 plus Cu. Okay, I arrange it and write it, Cu2 plus slash Cu, and this one minus E0 Zn2 plus Zn. Then what do we have? Minus RT by 2F. Let us take it common between this and this. So what are we left off with? We'll be left off with ln 1 by Cu2 plus. Now this is a plus and there is a minus out here, so we have to put a minus, ln 1 by, sorry, concentration, it will be concentration of Zn2 plus. So this is how this equation will condense further. Then this entire thing from here till here, this can be written as E0 cell. So E cell is equal to, this thing is written totally as E0 cell minus RT by 2F, and what was there? ln 1 by Cu2 plus minus ln 1 by Zn2 plus. So this is how it looks like now. So this also can be condensed further from the laws of logarithm. You know that ln A minus ln B can be written as E0 cell, this remains as it is, RT by 2F. Now this portion you can condense from the laws of logarithm, okay? So this portion you can condense it and you can write it as Zn2 plus divided by Cu2 plus. So this portion becomes this. So E cell. So this is the Nernst equation for the Daniell cell. This is how it is written. Now in page 72 you will find that they have done one more application of this Nernst equation to an equation where Ni solid plus 2Ag plus 2Ag plus aqueous gives Ni2 plus aqueous plus 2Ag solid. So this equation is done. For this equation in page 72, please try and solve in exactly, they have done it already in that page, but you can try and solve in this way. How I have explained to you for Daniell cell, you can apply it to this cell also, where the cell is set up between nickel maybe and silver. So this is the equation. Please try and solve this, and then you'll see it will be much more clearer to you how to get the Nernst equation for any equation given to you in this way. So if we apply for a general reaction, you see this was the E cell Nernst equation for which reaction? In a Daniell cell, what is the final equation? The final equation for a Daniell cell was given by ZnS plus Cu2 plus aqueous, arrow gives you Zn2 plus aqueous plus Cu solid. This was your equation, redox equation for Daniell cell. So if we want to write the Nernst equation for Daniell cell, after solving we see this is what we get. Now if we want to take a general equation, general equation means here you see all the coefficients are 1, 1, 1. Now this equation which I have asked you to see, there is at least one place where you have 2 here and another place where you have 2 out here. So it may not be always that you are getting coefficients 1 like you have in Daniell cell. You may have other coefficients depending on how many electron loss or gain is occurring. So likewise we can think about a particular reaction where we can have a general reaction in this way. We can have A, this is also done in page 72, you can have a look girls. AA plus BB gives you CC plus DD. This is a general equation where what are these small letters? These are the coefficients after balancing, and these are the species taking part in the reaction and giving you these. So how can we write the Nernst equation for this? So Nernst equation for this will be E cell is equal to E0 cell minus RT by NF ln of always concentration terms multiplied of the two products divided by the concentration terms of the two reactants. So this is the Nernst equation for a general equation like this. So here you can see the C is having a coefficient C, so we have to raise it to the power C. D is to the power D, A is to power A, and B is to power B, because the coefficients are there. In case the coefficient is 1, then the power also becomes 1. In case the coefficient is 2 or 3, likewise they will be to the power that much. So I think you will be able to understand when a general equation is given to you, how to write from this equation. So I think this is about Nernst equation.